Alright, so this is data analysis. So I was thinking originally we do the F mean, but I actually want to look at the F max. So first you should probably look at your data and evaluate it. I'll use orange again. So first off, I started this right here because this is highly suspect. See how different a result it is? This is most likely incorrect. So you might want to choose this to discard as data. Maybe talk about it, but it's a little unusual. Also, another one to look at, this one right here. I would also say it's off by a huge more of an order of magnitude. Everything is 0.0, it's automatically 0.4. It's almost half a second, which is unlikely. So I again would add it to the discard pile. So now that essentially we have to kind of cross off 2 points of data, I will talk to those people and try to get it fixed tomorrow so we can. I assume they meant 0.04 here. So now I'm going to get rid of some of that junk and erase those two things. So again, this is not a good thing, and this isn't either. So now what we want to look at is the high and low trends. So let's look for high force and low force and check off for there. So some high forces on our maxes. This is in the higher, these are all in the higher ranges, the 30s and 40s. And these ones in the lower ranges, more like 13, 47's high. So our 20s and 13s, I'm going to count as being low, and our 30s and 40s is high. So what you should start to see is now some times that go along with them. So as a general rule, if you look at your low ones, the lowest low one is 0.06, with it being averaging about 0.07 for the time. So low F had about 0.0 for your time, whereas the high ones seem to be smaller, ranging more around 0.4, so more on the average of 0.5 seconds, or 0.05 seconds. So high F generally equaled low T, and actually given our equation, this is what we'd want to expect. So looking at your data, you need to pull out statements. So for example, a statement to this: if there is high force, there is a lowered time. If there is a low force, there is a longer delta T. So you want to just start looking at data and starting to pull out trends and grouping your data to match. This is what we'll be working on tomorrow, as well as writing your tech report. So right now, I want you to look at the F mean and the delta T and see if you can find any, again, correlation between the two. So mark off which ones are your high F mean and which ones are your low F mean. And let's do that in blue. So high F mean is 16, 10, 15, 14, and let's say 12. These are all relatively high, and these are all relatively low at 10 and under. In fact, I'd actually probably count this 10 in the low category. And again, we're seeing the same trend. There's this high on the low numbers. At the lowest, they're 0.6. For most of your high numbers, they're at about 0.04. So again, a low mean meant a high delta T, and this meant a low delta T. So they are inversely proportional. Alright, so hopefully you can look at your data tomorrow of everyone's group and start making some statements like this. Alright, I would write down one of the statements I made, such as a high F mean meant a low delta T. And again, that has to do with your impulse equation. As this goes up, this goes down, so that this can stay the same for all of your experiments.